Before you start, okay? Before we start with trig, very important, otherwise you're going to get the wrong answers. At the top of your screen, you should see degree right here. Like the second last entry up here on your screen should say degrees. If it says radian, we're going to have to make some changes. I would just say everybody just follow what I'm doing just in case. So you want to press mode, the mode button, and then you want to go to the fourth entry, right? It says radian degree. You have two choices. You want to go over to degree and hit enter, okay, so that degree is highlighted. Chances are, if you're going to take grade 12 applied, we're going to use radian, and grade 11 applied, to use degrees, okay? So that's important before we get started, okay? All right, I hope everybody got that. Let's go back to our book and check your battery levels, right? So if they're getting low, think of charging them. Leave them here docked, and make sure it should be nice and easy to dock it, right? If you have to like hammer it into the slot, something is wrong. The tabs are not lining up on the sides, all right? Should be a light on the side of your calculator as well. It's going to be red if it's charging, green when it's done charging, okay? So in IAPR, that stands for Intro to Applied and Pre-Cal, last year, and maybe even earlier, sometimes some teachers do this in grade 9 already, you learned about, your teacher probably didn't use primary trig ratios. They probably only used trigonometric ratios. We use trig ratios for short. They didn't mention the primary word, but that's what you were learning about. So SOHCAHTOA or sin, cos, tan, or you may have seen the inverse operations. This is what we use to find angles. We're not going to use that anymore, okay? Does it still work? Yes, it works. But it kind of becomes a bit of an issue when you mix them up, and I don't want you to mix them up. So primary trig ratios only work with right triangles. In grade 11 applied, we will learn how to solve for oblique triangles. What in the world are oblique triangles? Well, these are right triangles. Okay, so you would have seen something like this, or perhaps something like this, right? It depends on how you interpret the problem. Okay, so you used SOHCAHTOA. I would have taught you SOHCAHTOA this way. SOHCAHTOA, right? Sine, cos, tan. Like so, if you had opposite and hypotenuse involved, you would use sine, adjacent, hypotenuse, cosine, opposite, adjacent, tangent. And if you're having nightmares right now about that, don't worry about it, because you're not really going to need this. Okay, I'm going to introduce. So these are right triangles because of that angle, right? If you have a 90, you've got yourselves a right triangle. We're going to now talk about oblique. So in the oblique category, you don't have a 90. So you could have something like this. Don't just get stuck on this, but this would be an acute triangle where every angle is less than 90. Okay? All angles are less than 90 degrees. That would be an acute. And then you have maybe one that looks like this. That would be an obtuse, because right, this one right here is greater than 90. So this is an obtuse triangle automatically if you have one angle bigger than 90. Okay, one angle larger than 90 degrees. Okay, and then you have an obtuse triangle. But combined, okay, we call them oblique triangles. You can also think of oblique as non-right triangles. Anything that isn't a right triangle is in the oblique triangles category. So right triangle, oblique triangles. The beauty is that with all of these, we can use sine law and cosine law to solve. It doesn't matter, like we now up it, right, to a degree where it doesn't matter if you're in this category or in this category, we can solve using sine law and cosine law. Okay. There you go. So, sine law, that's the first one I'm going to introduce to you. Okay. I'm just going to, this is my classic triangle example. I'm just going to go like this. I'm going to try to make all sides look different in length. So there you have it. Okay. So make a triangle like that. And then we're going to denote the angles with capital letters like that, ABC. And I would like to talk about labeling in this case here. So if you see ABC as the angles, right, we would call this triangle ABC. It doesn't matter, honestly, it doesn't matter if you label a triangle clockwise or counterclockwise, we're going to get the same answer, okay? So I know that some teachers taught you it's always clockwise. It really doesn't matter. We'll have the same answer. So if you see triangle ABC, I want ABC on the corners, and then by the standard would be to call, if this is capital A, then this would get lowercase a. So this is the side across angle A. If this is capital B, then this is lowercase b for the side length, and C over here. So that's the standard way of labeling. Okay, so you almost have a bit of a pair. Okay, paired up, paired up, paired up. So this is what sine law is saying. If I have time, I want to prove this to you, like an actual proof. It's longer, so we're gonna first learn how to use it, and then I'll show you why we know it works every time. Sine law states this, that if you were to take sine of angle A and divide it by the side across from it, that it would be exactly the same as sine of angle B divided by side B, and that in turn would be the exact same as taking sine of C over side C. That's what the sine law states. And this helps us to solve for missing sides or angles. Okay, so this is the sine law in a nutshell. If you want to add this to your study sheet, this is what you want to have on there. I will also say that technically, you could say instead of having all the angles on top, you can have all the sides on top and the angle at the bottom. You're going to get the same answer. I don't use this one, but I think it's fair to say, right, that you could set it up this way if you'd like. There you go. So that's a sine law in a nutshell. Let's see if that actually jives. So this is a short proof here, just by observation. You've got triangle A, B, C, okay? And you've got all side lengths. This is drawn to scale. Drawn to scale. So just so you know, these numbers are they're accurate. I use GeoGebra. I don't know if you've ever used GeoGebra or teachers. It's a free website. Just go there, and it's a mix between geometry and algebra. That's what it is. That's why they call it GeoGebra. So let's do some testing here. So let's take sine of A. So we're going to go sine of 22.7 degrees divided by the side length, which is 3.74. Okay? And then we'll take sine of B. Oh, is that an obtuse angle there? Yeah, not a big deal. Sine law can deal with it. There's a slight issue with it, but you don't get to see it until the very end. So until then, don't worry about it. Over 9.51. And then the last one is sine of 55.5. 0.9 degrees over 8.03. And now I want you to use your calculators for the following part. It's just to learn how to enter things properly. So what we're going to do is we're going to go sine of 22.7, and notice there's something that you need to keep in mind. It always has a bracket to start. Close the bracket or else it will mix it up with the numbers that are outside of it. So you want to close the bracket, then you go divide it by 3.74. You get 0.1032, right? If you go 2 decimals, that's what you get for this little. This is basically a fraction, right? Just a scary looking fraction. You turn that into a decimal. Let's do it the same for the other one. So sine of 101.39, close the bracket, divide it by 9.51. You get 0.1031 if you round to 4 decimals. Okay? And then over here, the last one is sine of 55.9. Close the bracket, divide it by 8.03. That's 1031 rounded to 4 decimals. Okay? So there's a bit of an issue with the rounding here. If I had given you angles that had like 4 decimals to them, I'm sure this would have all jived perfectly. So we're just going to say it's close enough, right? So this one is approximately that. So we use squiggly equal signs. And we have equal here. So, but we can see that the answers are very close, exactly or very close to each other. So this is proving to you that if you have a drawn to scale triangle and you were to actually apply the sine law, that it is true, okay? Let's keep going, and now we're gonna actually solve for missing sides first, and then we're gonna do missing angles next, all right? Page 3. For sine law to work, you need at least, what does it say there? 1 pair. That's important. And what do I mean by that? This means that you need a known side and angle opposite to it. Okay? Morning. So these are the only 3 scenarios where sine law works. Okay? You could have this scenario. So let's draw 3 triangles here. Let's make them all look about the same. Can I just ask you to go a little higher in this box with a triangle so I can maybe add another one if I need to? Draw 3 triangles, and then we'll talk about each scenario individually. Okay, so here we go. The first one is when it doesn't matter, but you'll have an angle here, so you will know that number. You will know another angle, it doesn't matter. So in this case, you know 2 angles and one side, right? One side across from either one of these angles. So we look at it that way. This is what we call angle side. Then the other scenario is where you know 2 sides, doesn't matter which 2. And you'll know one of the angles opposite to one of the sides. So you might know this angle here or this angle across the other side that you know. So I'm just going to put it over here. So this is what we call side-side angle. And to be honest, it doesn't matter. Some students, I just don't use it because it's not appropriate, but angle, side, side, what would that spell, right? So I don't use that. But if that helps you to remember, you go for it, right? And the next one is, watch this one. This one is probably the trickiest one, is you know two angles. You will know two angles, so let's say these two angles here, and you'll know the side that connects those two angles. Okay? So this one is angle, side, angle. So the side is kind of in between. Let's talk about what's most important to me here. Do you see a pair here? Like a check marks mean those are going to be numbers. This is what I call a pair. If you have the angle and the side across from it, that's a pair. You can put $100 down every time. If somebody were to bet to you, is this going to be sine law? You're like, yep, it's sine law because there's a pair. Boom, put $100 down. You'll win every time. Okay? Over here, do you see a pair? Okay. I see it. You know it's going to be sine law. Do you see a pair here? No, you don't, right? Can you get a pair? If you know two angles, you can get the third angle no problem, correct? So we can go, I'm going to just do this. Sum of triangle is equal to 180 is going to give you this angle right here. So actually you do have a check mark automatically there. Okay? Do you have a pair now? Yeah. I'm just going to say this one is called the hidden pair. Oops. So I don't know, to make you remember this, right? This is like the pair that's hasn't announced yet that they're dating, right? So they're not holding hands in the hallways or anything like that. So they haven't announced it yet. So now you'll remember. But anyways, you always have a pair, okay? That's what I mean by pair. And that is the easiest way to figure out is the sine law. These up here, guys, honestly, I couldn't care less really if you remember that or not. But these are the official 3 cases that work with sine law, okay? And I'll also give you a heads up already. There's sine law and cosine law. That's it. There is no tangent law if you're waiting for that one. It's just going to be sine law, cosine law. Sine law has 3 cases that it works for. Cosine law only has 2 cases that it works for. That's why most of the time you'll be using sine law to solve things, all right? So just a heads up already. Continue. This is important. Please remember this one. It's so, I know most of you will make sense of it, but sometimes we forget that. Largest angle is going to be across the longest side. So this is a way to check, are you doing your work right? Is your work adding up? Okay? Smallest angle is across the shortest. And it obviously, the middle angle, the side across from it is going to be the middle side, right? Like that, the one that's between the shortest and the longest. That's it for that. Just remember that. I think that deserves, because sometimes I'll be like, you know, Joey needs an angle of at least 45 degrees in one of the corners to make this work. You should be checking for the largest angle. If the largest angle is 45 or greater, you can definitely say, yeah, there'll be an angle that will work for Joey, right? Instead of solving for all 3 angles, which is very time consuming. Okay, drawing and labeling, we just talked about this. Am I changing anything here? I feel like I made a note. Triangle DEF. Oh yeah, do you see two angles? Angles D and D, that's what I made. I have to fix that. Let's call this angle F. Okay. So if I ask you to draw a triangle, can we also change the 50 to an 80? Can we make that an 80? I'll explain in a bit. So it's angle F, and that's 80. So if you see triangle DEF, you can confidently do one of these. Right. We know it's acute because so far none of the angles is greater than 90. And I'd usually start here, D, E, F. But you could start in any corner and just go clockwise or counterclockwise. It's going to work. So if this is capital D, this is lowercase d, lowercase e, and lowercase f across from angle F. Okay? And then I would like you to enter the values, right? So angle D is 60 degrees. Side D is 5.2 centimeters. Angle F is 80. And side F is 8.3. So we go over here. It's not drawn to scale, so don't worry about. Technically, I should make this the longest side, correct? It is what it is. So that's what I would expect you to do. When labeling, we use uppercase letters for angles, lowercase letters for sides. That's all I'm going to say. I hope that you have been taught this anyways, but sometimes I need to review it. Okay, so that's what you would want. In this case, do you have a pair? This is a pair, right? And you have another pair here. So it's like double sine law, right? You can double down on your bet. Anyways, that's not the point here of solving. It's just to label. Okay, let's apply this. Let's actually do some solving here. How would we use the sine law? I'm always going to assume, I'm assuming that we already know cosine law and you have to decide between the two. That's why I solve the way I solve. Okay? So you look at this triangle, you have a diagram. Sometimes you won't have a diagram. And you look at everything and you see a pair here. Okay? And so that, you know for sure, use sine law. Okay, for sure because of that pair. In fact, I will always suggest you start with that pair. Sine of 62 degrees is paired up with 4.5 meters. And then you're going to go equals. What is it that we're trying to solve for? Side B, correct? That's what they're asking us for. So let's go over to side B, which you should know is this one right here. Question mark. That's what they're asking us for. But as it stands, look up carefully. We don't know angle B, right? So far we cannot do it. So let's just solve for angle B first. Okay? Angle B is 180 degrees minus 38 minus 62. I would actually suggest when you have two angles, just go ahead and find a third one. Chances are you're going to need it. And if you do this, you end up with 80 degrees. Important, but not our final answer. Okay. So now you can actually write that in. We know that this is 80. And so, because we want side B, we're going to use this angle. Okay. Let me just do this a little longer than what you will be coming up. You would actually go sine of B over B. Then let's substitute in. Sine of B is sine of 80. Okay. Over side B like this. And you should see cross multiplying and dividing here, proportional reasoning. So remember, I always go to the side where my variable is. That's where my journey is going to start, on the right side. This is technically a number, right? So you multiply going this way, and then you divide by what is left. So this is how I'm going to solve it. I want you to show me the steps though. So it's 4.5 multiplies sine of 80 degrees. That divides by sine of 62 degrees. And now you want to grab your calculator and does it, 1 second here, does it matter if it's sine of 80 times 4.5 or 4.5 times sine of 80? It doesn't matter. It's like 2 times 3 is 3 times 2, right? Two things multiplying. The reason I put it in front, guys, to be honest, is because then I don't have to worry about the brackets for the angles here. I'm just going to go 4.5 times sine of 80 like that. I don't even have to close the bracket there on my calculator. I can just hit enter. And then I go divided by sine of 62. Sure, if you want to close the brackets, it doesn't hurt. So that's your side B right there. 5.02, right? And we are in meters. You've just solved for the side there. One more. Remember, this is just the intro or working towards word problems. That's where it always ends up, right? Okay, over here. Do you have a pair? At first glance, you don't, right? But remember, if you have two angles, you can find a third. So you have a hidden pair. So let's find angle C here. If you use your calculators, you're going to get 65 degrees there. Important, but not my final answer. Usually you get a mark or half a mark for this step here. So you get 65 in there. You now have a pair. So if you have to do some work to get your pair, do it. Okay? Do it, and then you'll see sine law, right? Because of that pair, sine law. So here we go. Sine of 65 over 14.5 meters is equal to. Which one are they asking for? Side A, right? Let's put a question mark here. This is what they're asking us for. So which angle am I going to use? I have to use this angle here, right? So that angle is going to allow me to solve for side A. It always goes in pairs that are opposite each other. So when I have to go sine of 30 over A, side A like that. And so you cross multiply, in this case you start here, right? You cross multiply this way, you divide. That's not work technically, this is just like a little, I don't know, shortcut just to help you out. So it's 14.5 multiplying sine of 30, then you divide by sine of 65. And what do you get there? Should be getting 8. 14.5 times sine of 30, I hit enter, divided by sine of 65. 7.999, so that's an 8, right? Let's see if you're on the right track. The largest angle is 85, right? So this should technically be the longest side. 30 is the smallest angle. So this should be the shortest side so far, right? And it is. 8 is shorter than 14.5. So you're doing okay, right? It's adding up. So Let's do, I didn't plan for it, but what if the question said side B? Solve for side B. Can I just, I want to highlight the pair. If I'm just going to do this. This is the pair that is given to me right from the beginning. That is the pair I started with there, right? So sine of 65 over 14.5. I would always suggest stick with the pair that you were given from the very beginning by the problem, okay? So if you want to solve for side B, this is side B here. Guess what I would do? I would start with the same pair as before. But which angle would I use now? Yes, I would use the angle B, which is 85 degrees. And then I can solve for B. And I will highlight this again. It's the same pair. It's the original pair, basically. So side B is going to be found by multiplying this and dividing. Okay. So 14.5 times sine of 85 divided by sine of 65. So if you don't mind entering that, just to practice, right? That won't hurt you. $15.94. Does it make sense? It should be the longest side, right? Because it's across the largest angle, and it is the longest side. So this is the longest side. It's a little bit of a check there. And this is the shortest side. Also a bit of a check. Okay. So we're doing okay. It adds up. All right. Before I do angles, I'm going to ask you to try at least one before we move on. Excuse me. Let me just see here. Let's go to page 5. And maybe I'll get you started before you solve. No diagram, correct? Oh, I'm doing angles right away. We'll do angles. Let's do that. Yeah. And then you'll have to do some on your own. Okay. Applying the sine law to angles using the inverse function of sine, which is sine inverse. So triangle XYZ has the following dimensions: side X, side Z, and angle X. Can I just tell you something already? I'm foreshadowing here. That's a word you don't hear on a regular basis, right? You see angle X and side X. Okay? This is a pair. Just think about it. You have angle X and you have the side across from it. Okay? So therefore, sine law. So without even sketching it, you already know that you're going to have to use the sine law. It's just to confirm what you're going to find out anyways. Okay? Sketch a triangle, then calculate the values of angle Z and angle Y. So let's do A here. If you don't know what it's going to look like, this is the safest way to do it. Just go like this, like a slanted roof, go to the top, and then make the other side of the roof a little longer. That's usually what I do, so that it's not an isosceles, right? We don't know that yet. And then we start here, angle X, Y, and Z. And let's fill in the values we know. Angle X is 34. Side X is 6.2. So I'm going to put that here. I'm also given side Z, which is 3 centimeters. This is angle Z, so side Z would be over here. And everything else is unknown to us. You see the pair? There it is. Therefore, sine law. Again, right? You see that it's jiving. I like you to have multiple ways of figuring out if you're on the right track. Okay? So, let's see what we can do. We have the pair, so that's going to for sure be the thing we start with. This side is the only side you know. That would allow you to solve for which angle? Angle Z, right? That's the only thing you can do at this moment. So we're gonna go angle Z. We're gonna solve that here. Start with your pair, just like before. So sine of 34 over 6.2. And on the other side, you're going to go sine of Z over 3 centimeters. So here you see how it's different. We're missing an angle here. And watch how you solve this, just like before. Your variable is on the right side. If you solve the way I solve, it's going to be the case every time. You multiply, then you divide. So the way you multiply, now you multiply up, across, and then divide going down. So you have to be careful here. A lot of students just put Z down. It's sine of Z is equal to 3 times sine of 34 divided by 6.2. And I'm normally not a big fan of having things equaling each other like a bunch of times, but it actually would be accurate to do that here. So what I would like you to do is I want you to turn this into a decimal here. So we're going to go 3 times sine of 34. Okay, we multiply, hit equals or enter, then divide it by 6.2. That way you can tell if you did this right later on. If for whatever reason the answer is wrong, I'm going to go check for this decimal here. So let's write down the first couple, 0.270 continued, right? But we're not going to round. We're not going to round. So here's your final answer. Angle Z is going to be found by going sine inverse of that number. So write that down and I'll show you on the calculator how I do it. You have to press second. And as soon as you press second, you'll see an arrow going up. Then you have to press sine, which is right here, under the apps button. That's now you have inverse sine. And then you have to go arrow up, copy paste that decimal into the inverse function. And then hit enter one more time. So it's 15.70 if you round that. Okay? So angle Z, it's a little tight here, I apologize, is 15.70 degrees. Yes, you have to round to 2 decimals. I'm pretty sure your teachers last year may have asked you to go to the whole round number, right? To the nearest degree. We do 2 decimals. That's even with the grade 12 applied exam. Always 2 decimals as your final answer, okay? Especially when it's money. Technically, you could go more than 2 decimals if you'd like to, as long as it's rounded correctly. but 2 is the minimum. So I'm going to teach you that over and over. Now angle Y. Angle Y. Can you use sine law to do that, that part? You could, but sum of triangle is the way to go because you've got two angles now, right? So we're going to go angle Y is 180 minus 34 minus 15.70. So don't be using sine law again because that would be very long, a long journey for you. So you get 130.3 degrees. That's your angle Y right there. It's an obtuse angle, by the way. Obtuse angle, therefore, it's an obtuse triangle as well. It turns that whole triangle into an obtuse triangle. Okay? So just giving you a heads up. We can still work with them, no problem. Okay? I take it one step further. So, by the way, this is going to take us back to what I started with today, this morning. It says, solve for side Y. We want to know that last side that's still remaining. Okay? Watch this. I'm going to start with a pair just like before. 6.2. And on the other side, I'm going to use sine of what? If I want side Y, I need to use angle Y, correct? Which is right here. So we're going to go sine of 130.3 degrees. And just make a note. This is angle Y. Okay? And that's going to allow us to solve for side Y. I'm going to scroll down a bit so you can see. And here you solve just like before. Cross multiply and divide. So 6.2 times sine of 130.3 divided by sine of 34. So what you want to practice is notation, right? Especially when it's solving angles. 4, 6, and we are in centimeters. It's a side length, right? Does it make sense for it to be 8.46? It's the longest side. It's across the largest angle. So yes, we're on the right track. So that's, I mainly want you to use that to check your work. Because sometimes you'll forget to divide or you'll make a mistake in your setup and you're like, you get, let's say you got 4.7. You're like, 4.7, that can't be. It has to be longer than the other sides that I used, right? Longer than 6.2 for sure. Calculate the perimeter of XYZ. Do you remember what the perimeter is? Distance around. So let's see, this is going to come in here and there on your homework questions or whatever. And so perimeter is simply going x plus y plus z. And so that would be 3 plus 8.46 plus 6.2. And that's 17.66 centimeters. That's it. All right, I'm going to stop there. It says multi-step questions on the. We're gonna wait with the multi-step for now. I'm just going to ask you to go and try. Yeah, I'm just gonna make sure I cover the ones I want. I was going to go 6 to 11, but I think I'm going to go 6 to 11, but I understand if 11 is a bit of a challenge for you. Actually, 7 to 11. Okay, so I'm going to write this down on page 5. 7, 11. Who doesn't want the Slurpee when it feels like -4? All right. So pages 7 to 11. So 7, 8, 9, they're all basic. Just solve for what's missing. And then page 11, maybe if you could go to 11. Just 11, I'm giving you a picture there. The question is asking you for that dashed line. So you might want to split the triangle up and solve for sides, see if you can do it. So I don't blame you if you can't do 11, but I think it's a good challenge. Remember, you're awake, right? Sine law and cosine law works with right triangles as well. It works for every case. So if you happen to have a right triangle, you can still use sine law for it. And sometimes students forget that that box means 90, right? So you've got sine of 90 across from whatever is across from it, all right? So this is definitely more than just one step. You're going to have to solve for multiple sides. But anyways, don't worry about it until then. Pages 9 and 10 asks you to actually sketch and then solve, okay? So just be mindful of that. But 7 to 8 just has diagrams to solve. So maybe 7 and 8 to warm up, and then 9 and 10 to take it the next step where you have to sketch. And then 11 is, I would say 11 is optional, but strongly recommend, okay? Rest of the class is yours. Thank you, guys.